the London subway system, and its use of kinetic and potential energy to conserve the motion of vehicles. This project was done by Sam Mantell, Alex Murphy, and Eric Finney. When London wished to expand its subway system in the late 1800s, it unfortunately had run out of space close to the surface. Thus, it had to start tunneling deep underground, making the first tube railway in the world. When it was built, this railroad faced numerous challenges. In addition to being drilled deep underground, it was also the first railroad that was going to be propelled with electric power. Unfortunately, at the time, electric motors were very weak and were unable to sufficiently accelerate and decelerate the trains to the required speed. To overcome this problem, the chief engineer of the line had an ingenious solution. Stations on the line would be built at higher elevation than the surrounding track. This would enable trains to be accelerated by gravity when leaving a station, and decelerate also by gravity when entering a station. Today we know this effect as the transfer from kinetic energy into potential energy, and then back into kinetic energy. When the train is moving on a flat surface, it is neither accelerating nor decelerating. The only forces acting upon the train are friction, which tries to slow the train down, and the power from the train's motor, which attempts to counteract friction and keep the train at the same speed. When the train begins going uphill, it has both the force of friction slowing it down, as well as the force of gravity. As you can see in this video, when the train reaches the slope, it begins drastically slowing down as it converts its forward motion into potential energy gained from height. When the train is ready to leave the station, the train's motors slowly pull the train out of the station towards the slope. When the train hits the slope, it begins rapidly accelerating, converting its potential energy into kinetic energy. As you can see, even a slight incline drastically increases the train's speed.
Two, one. Perfect.
Thank you for watching our physics presentation.